All right, welcome to this pre-exam confidence booster explainer. I am your senior math tutor, and look, today we're going to completely transform the way you handle integration by parts. If you're preparing for a competitive calculus exam, you already know that time is your absolutely most precious resource, and careless algebraic mistakes are your worst enemy. So today I'm going to show you how to conquer those intimidating integrals using a highly efficient technique known as the tabular method, also sometimes called the DI method or the tic-tac-toe method. Okay, let's take a quick look at the syllabus for our review session. We've got 1. The ultimate exam shortcut. 2. Choosing U and DV. 3. Scenario perfect termination. 4. Scenarios matching and repeating. 5. Scenario shrinking terms. And finally, 6. Our pre-exam tabular checklist. Let's dive right in.
So, Section 1, the ultimate exam shortcut. I mean, just look at the difference here. On the left, when you have a high-degree integral, like say x to the 10th power times cosine x, the traditional formula literally forces you into 10 nested applications. You end up with an absolute nightmare of nested brackets and alternating signs. And we all know how it goes. You miss a single negative sign in bracket number 7, and boom, your entire answer is shot. But look at the right side. The tabular method completely replaces that chaos with these clean, highly structured columns. Now, what's really fascinating here is the psychological reason this trick works so perfectly for exams. It's all about this concept called visual cognitive offloading. Basically, by separating your alternating signs, your derivatives, and your integrals into isolated vertical tracks, you dramatically free up your working memory. You aren't trying to juggle the calculus and the algebra simultaneously in your head. You execute one simple task at a time, which totally prevents those cascading sign errors.
Moving right along to Section 2. Choosing U and DV.
All right, before we can draw any tables, we need to pick our variables. To guide you, we have two classic memory aids. Depending on your preference for coffee or tea, you can use Liate, which sounds like latte, or Lifty, which sounds like Lipton tea. These acronyms tell you which function to pick for your U variable, meaning the one you're going to differentiate. Liate stands for logarithmic, inverse trig, algebraic, trig, and exponential. Lipton is the exact same, except algebraic is swapped for powers. It's super simple. Just pick the function that appears first in this list, and whatever is left over becomes your DV to integrate. But hey, as your senior tutor, I've got to warn you, please don't follow rules blindly on the exam. When simple parts don't easily simplify, you have to use what we call the opportunistic method. Take an integral like x cubed times e to the x squared. If you blindly set u to x cubed, your DV becomes e to the x squared, which you actually can't easily integrate. Instead, you must conceptually partition that difficult integrand. Split the x cubed into x squared and x. Then you can make your u equal to x squared and your dv equal to x times e to the x squared, which is easily integrated using a standard substitution. Always look for that opportunity.
Okay, Section 3. Scenario. Perfect termination.
Let's say you're staring down the integral of x cubed times sine of x. Following our rules, x cubed goes in the d column for derivatives, and sine x goes in the I column for integrals. Now, watch the d column. We differentiate x cubed to 3x squared, then 6x, then 6, and finally 0. When your derivative column eventually hits 0, you achieve perfect termination and you can just stop writing. You also generate your alternating sign column, always starting with a plus. In theory, by the way, these alternating signs exist because every time you nest the traditional integration by parts formula, you distribute a new negative sign from the integral of v du.
So, how do we construct the final answer? It's literally just a game of tic-tac-toe. By shifting diagonally across the grid, multiplying the u term by the integrated v term directly below and to the right of it, and applying the alternating sign from the first column, you entirely bypass all the tedious algebra. You just write out the sum of those diagonal products, tack on your plus c, and you've got the answer in seconds.
Next up, Section 4. Scenarios. Matching and repeating.
Now, what happens on the exam if the derivative column never reaches 0? Take a look at this table for integrating e to the 2x times cosine x. If we differentiate e to the 2x, it just keeps generating more e to the 2x terms. It's never going to hit 0. Similarly, integrating cosine x just cycles between sine and cosine. For repeating patterns like this, you have a specific stop condition. You stop building the table when you generate a horizontal row that matches the terms of your original integral. Right here on the third row, we have an e to the 2x and a cosine x. That is our match.
When you hit that match, you gather your diagonal products just like before. But for that final matching row, you multiply it horizontally to set up a new integral. Because this new integral contains the exact same terms as your original question, you have essentially created an algebraic equation with like terms. It's brilliant. You can simply add or subtract that entire integral over to the left side of the equal sign, combine them, and then divide by the coefficient to isolate and solve the integral algebraically. It completely circumvents getting stuck in an infinite loop.
Section 5. Scenario: Shrinking terms. Let's look at a case like the integral of x cubed times the natural log of x. By our laity rule, the natural log goes in the derivative column and x cubed goes in the integral column. Now, if you take the derivative of the natural log, it yields 1 over x. Notice that 1 over x is never ever going to hit 0. However, look across that horizontal row. If we multiply 1 over x by our integrated term, 1/4 x to the 4th, the x's cancel out beautifully. The terms shrink.
This is the concept of horizontal viability. As soon as you notice that your horizontal product becomes a simple, basic integral, you just stop. You simply sum the diagonal products as usual to start your answer, and then you directly integrate that final, simplified horizontal slice, applying its alternating sign, of course, to complete the problem.
All right, final section, Section 6, Pre-Exam Tabular Checklist.
Let's rapidly review these stop conditions so you can mentally screenshot this for exam day. First, 0. Terminate instantly when the D column hits 0. Second, matching. Stop when a horizontal row contains the same functional terms as your original integral, allowing for that algebraic solve. Third, shrinking. Stop when multiplying horizontally creates an expression you can easily integrate in your head. And finally, repeating. Watch out for cyclical boomerang functions like those exponential and trig pairs, where you know in advance you'll be hunting for a match.
I absolutely love this quote from academic research on the topic. Trust in this organized method, guys. It is going to radically offload your cognitive burden, eliminate those incredibly frustrating nested sign errors, and drastically improve your test-taking speed. It truly strengthens your confidence because the layout literally does the heavy lifting for you.
So before you walk confidently into that exam room, I want you to consider this final thought. This isn't just a high school shortcut. The structural elegance of this tabular method is actually used by professional mathematicians to systematically prove complex theoretical results, like the remainder terms in Taylor's theorem and bounding the frequency parameters in Laplace transforms. It really makes you wonder, if it systematizes calculus this perfectly, how far up the ladder of advanced theoretical mathematics could this simple tic-tac-toe trick actually take you? Good luck on your exams, everyone, and keep exploring.